Hi everyone, it's really nice to be here. I'm really glad that I'm not late because I noticed that you changed this location like 40 minutes ago, so that was a real rush. I was already going to Makoto Gallery, and it's also very nice to be a speaker on WRUG meeting because those meetings really helped me in my career. So thank you guys for having me here. A few words about me. My name is Marek Parafianowicz. I'm a Ruby on Rails developer in NetGuru. You can contact me using mail or my personal email, just the same but with gmail.com, or use LinkedIn to contact me. I am also active there. So, we will talk today about full text search in Postgres. How many of you already use this feature of Postgres? I think that's pretty many. Okay, unfortunately, you will not probably learn a lot during this presentation because it's mainly aimed to the people that haven't heard about it, haven't used it yet, but I hope you will not be bored by it. So, what is it? This is the only slide that I will read, but it's really good definition from... Oh, okay, thanks. Okay, so this is very good definition from the Postgres documentation. Learning this feature of Postgres, I was using only this documentation. It is really nicely written, very simple. So, full text search provides the capability to identify natural language documents that satisfy a query and optionally to sort them by relevance to the query. The most common type of search is to find all documents containing given query terms and return them in order of their similarity to the query. So, what's the most important part of this definition? Is that we will be dealing with natural language documents. What are the documents? The documents in the Postgres context are just text fields, text data or long strings, but with natural language, so sentences, words, and so on. So for example, documents might be articles that have very long text, or maybe products description, comments, even logs from some application. What else? We will... Oh. Okay, sorry for that break. Okay, and we will query those documents using also natural text very often. So some sentences, words, and so on. This is very important that it's natural language because we use different forms of the same word, so singular form or plural form, and so on, and synonyms. So it is not very easy to search this using other features of Postgres. Okay, can you change the slide? Okay, so for example, like and I like also can be used to search those documents, query documents, but they do not support linguistics. They don't have default ordering, or it just needs to be written by you, and they are slow because there is no index support. That is not entirely true. You can use probably GIN index for that, but that's not very obvious, and it's much easier to use full text search in this context. Okay. So, to start processing full text search, we need to do pre-processing, and that contains a few steps. First of them is parsing documents into tokens. So, just identifying numbers, words, complex words, emails, and so on. Then Postgres converts them into lexems. So it identifies real words and just normalize them to make them more alive. So, for example, it folds uppercase letters to lowercase, removes suffixes, eliminates stop words, for example, and, the, and so on, because they are not linguistically important for our search. And how does it do this whole magic? Postgres uses dictionaries. So Postgres supports many languages: English, Spanish, German. Unfortunately, not Polish. That's a bummer, but probably because Polish is hard. And it is optimized for searching. I will show you how. Okay. So you can write something like this. Select to TS vector. TS vector is a data type used in Postgres to store this tokenized natural language sentences. So, for example, we have this Hey Warsaw Ruby users group. Ruby on Rails is still a valid framework based on Ruby language, right? And it's a sentence in English. So when we use this function to change the data type to TS vector, it returns something like this. Base 14, framework 13, Rail, Ruby 3, 6, 17. So what is going on here? All the words are lowercase. There are no stop words, so no on, no is. There are also no punctuation marks here. And also it does something strange with few words. For example, Ruby. And that's probably because of the plural form of the Ruby. And what about the numbers? I think you know what are they? Any guesses?
Position.
Yeah, it's a location of the word in the original text. It will be used in the further searches. Okay, next slide, please. So you may ask me now, after this introduction, did I forget about true search players, Elasticsearch or Solar, so on? No, I didn't. They are great, really great, much better than Postgres full text search, much faster. And they have much more options, but it depends on the context. So the usefulness depends on the context. If your application is mainly focused on the search, so for example, you have millions of articles, millions of logs, or even billions of them, Elasticsearch is perfect for that, to query this massive number of documents. But not always you need this kind of canon for your application. Okay, next. So my use case. I had a side project in NetGuru. It was to analyze NetGuru's blog. We had many interesting metrics related with the blog posts, for example, links between them. Really interesting project. One feature from this application requires fast search of keywords among our a little bit more than 1,200 articles. And writing this application took me far less than preparing this presentation. One moment. And I bullet a few words here. Side projects, many. One feature, far less time. So, as you can see, that was not my main project. I was not on the bench. I was doing this after my hours just to help colleagues in marketing department. The application had only one feature that used this search. Many other metrics don't even need this kind of search. And at the end, it took me really not so much time. I might say few hours, just because it was really interesting to dive deeper into this topic that I had to. Okay, next article, please. So, how to do this? In this context, we will use one of the tables from the real project. It is a sites table with content that is text data type. Other columns are irrelevant for this. And one question to you: do you recognize this kind of code? From which file is it? Schema, but not. Yeah, and that's important because we will need this into our project if we use Postgres full text search. Next slide, please. So we will need structure SQL to use few options of Postgres that will be not written down in default schema. It's really easy to set this just in application RB set active record schema format to SQL. That's all. Okay, next slide, please. So, to prepare these documents to be searched, we need to set an index because without index it is really slow, and I will show you how slow on just 1,200 documents and much more documents. Maybe not much more because it will be really slow. So we will prepare this index. To do this, we will create a new column with already parsed documents to the TS vector type. So in this migration, I add column to the sides that name is TSV content, and data type is TS vector. And then I need to execute some SQL. First of all, I will populate this new column with the lexems, so the lexemized tokens that are that have data type of TS vector. So that's all. Just changing content to the TS vector type. Then we create index and a trigger to always update this TS vector column whenever we update or insert anything in a content column. Okay, so here are a few notes. Most of them I already told you. Data type, yes. Two cool things about this 2TS vector. As you can see, here we have a language. That is important because we need to tell Postgres which dictionary to use. But language can be specified by another column. So we can create another column in this table if we know what language is the corresponding article or document. That is pretty neat. And we can also merge two columns, many columns, how many you need. We can even add weights to them. That is also cool thing. But what are weights? We can say that, for example, if we search using title and content columns, we can say to the query that the title is much more important in our search than content. I think that's real life scenario. In our application, unfortunately, in most cases, I didn't have titles of the articles, so I only used content. Then, about this GIN index. You have two indexes to choose from, GIN and GIST. They have their pros and cons. GIN is the default index because it is not false positive like GIST sometimes. So GIST sometimes need to do another query to be sure that the result of the search is not a false positive. So GIN is much more precise, but at the same time it's much bigger, so it's slower to update the base column. So in our case, content. If you have static data, as we do, just articles, and we will add really not so many articles over next years, GIN is perfect for us. But if you have really dynamic data that you need to update them really frequently, GIST might be a better option for you. Okay, and the last part is some nice addition but not only addition, it's required to make this reliable. So whenever we update something or add to our column, it's automatically added to the TS vector column. Okay, next slide, please. That is only a down version of this migration. So drop trigger, remove index, remove column, not interesting. So next slide. And the queries at last. So how does it work to use this query in Rails context? It's simple as that. So we just make a string with our query, and then we put it into where method. And what queries can we use? Because query is TS query is another data type in Postgres. So we need to make a query, then translate into TS query, and just use it on the column that is already tokenized into TS vector. We can also do this on the run. So here we don't need to use our already made column and just do this two TS vector methods on the run, but it's much slower, so I do not recommend that. One more thing about this column, you don't need to always make this column, but you can use also Postgres views, materialized views, and so on. But this additional column just makes it much easier. So, what queries do we have? Phrase to TS query. That is a really neat one. So, I use just some query from the params, and for example, how we translate the fat rats to the TS query. The fat rats, the is removed because it's a stop word, not really important for our search. So the Postgres only is looking for two words that are in close proximity to each other. So no other words is between them. But when we put this the between the two words, Postgres knows that it needs to find fat and rat and any word between them. So any other stop word or any other lexically meaningful word. Okay. Plain to TS query is also very useful because it translates words into this and logical, how to call it, I don't know, but it removes also stop words. And in this example, the fat rats, it will search for these two words in the document. The proximity of the words are no longer important for this query. So both cases are the same using plain to TS query. And the last example, probably the coolest, web search to TS query. So we can accept something like more complicated web search, and Postgres will translate into useful queries. For example, this sad cat or fat rat will search for these two queries with the or. And Rails minus Ruby, it is to trigger you a little bit, so we'll search Rails without any Ruby. Okay, and that's all. So it's time to show you the app a little bit. Okay. Yeah, okay. That's fun. Thanks. So this is my app. We will search NetGuru blog for example, Rails. And this first search doesn't use any indexes. So let's take a look. Searching. Maybe they have crashed. Oh, no. There are the results. We have 16 pages. So many articles are about Ruby on our blog. I recommend to look into those articles. They are really cool. So, is there any Ruby? Okay, there are Rubies in this article. But let's compare this with a search with an index. Okay, it's done. So Ruby, same. Python, same. Okay. Plain to TS query. So with AND operator, Ruby, Python. Let's take a look. So both of them should be here. Okay. Okay, and the proximity isn't important in this search. And the last one, how was it? Rails minus Ruby, something like this. there is Rails and no Ruby. Okay, so it's working. One more example. I have also a blog with many more articles, and let's look how fast it is. Marketing, 248 pages with results for marketing. So let's go back to the presentation. Summary. It's fairly simple. You must admit there wasn't many steps to implement this mechanism. It has many query options, obviously not as many as Elasticsearch. It doesn't require external dependency, so you don't need to set up Elasticsearch. You probably already use Postgres in your application. And sometimes it's just good enough. It can be fast. I know that people are using this Postgres full text search for millions of documents and it's working for them. I would probably use Elasticsearch, but if it works, it's good, okay? So it's good enough, and yeah, thank you. Any
So I'll be passing on that microphone with the questions.
Maybe
I'll start so to just maybe show like how dumb a question can be so that you don't feel bad about yours. Okay, so do you know what's the amount of data when Postgres text search gets slower than Elastic or Solr or any dedicated solution, or noticeably slower?
I think it's slower from the start, but that's a very good question. How much more slow it is than Elasticsearch? To be honest, I'm not sure, but yeah, I think that it's the first thing is that Elasticsearch gives you more options. So when your application really requires more searches in its logic, for example, it's really important for this app to make some complicated searches, or you predict that they will occur in the future. I will start with Elasticsearch for millions of documents and so on. Maybe not for millions, but if I know that it will be more complicated, I will start with Elasticsearch. But going back to your question, I'm not sure, really. That's the cool thing to check.
And more questions? Okay, cool, thanks.
Thank you.